Hello everyone, welcome back to another episode of my CDK crash course. In today's video, I will show you guys how to set up the database for our backend system using DynamoDB. Let's have a quick recap what we have from the previous video. We have a backend system with one endpoint, the get health, and we managed to add the authentication to our system. So in order to consume this API, first we have to log in to grab the token like this. After that, we start consuming our API. So for those of you who haven't watched the previous video, I strongly recommend you guys to do so. But if you guys don't have time for that, I still leave the link to the previous video code in the description. So check it out. That will be the starting point of this video. So without further ado, let's jump to VS Code and start implementing our change. So I have finished implementing the change to our CDK stack. First, I create a new class called Dynamo. This extends from the table class, which is a Dynamo table. I name this table to_do_db, and there's a partition key and a sort key. The partition key, I name it type. The reason I chose this is because later on we have a request to get all the to-do in our database. So I can just make the query via this partition key. For the sort key, I use ID. So if we want to target any specific to-do, we can make the query with the combinations of the partition key and the sort key. The example is quite simple enough, so I will not add any index, whether it's local or global in here. In the Lambda class, I add this line to add to row policy with 4 policies: query, delete, put item, and update item for the Dynamo. What it does is CDK will create IAM policy row for us and assign it to our Lambda. Finally, in our main stack, I initialize our database here. I create 4 new Lambdas, which is create, get, update, and delete. And I assign our Lambda to our API right here. Currently, our Lambda does nothing but just return some string in the body. Now I will use the CDK deploy to update this change to our CloudFormation stack. This process will take some time, so I will fast forward the video. So the CDK deploy command has finished. Now let's log into AWS console to see the result. After I log into the AWS console, I'll go to the DynamoDB. You guys click on the tables tab right here. You can see a newly created table named todo_db. If we click on that, you can see that it has a partition key as type and the sort key as the ID, and they both have the type of string, which is what we wrote in the CDK code. Currently in our table, there's no document. Now let's go to the Lambda tab. You can see that there are some new Lambda that created for us by CDK, such as to do, create, get to do, update to do. If we go to any of them, let's say we go to the create to do Lambda, and we look at the code, you can see that the code we wrote in our CDK stack will be shown here. Create to do Lambda executed, and the body and the status code exactly as we wrote in our VS code. So that are all the changes that I will have in this video for the CDK. Now we will implement the change in our Lambda code. Let's switch back to VS Code to do so. So I just finished implementing the code. Now let's go through the folder structure together. So for the folder structure of this application, I follow the concept of separation of concerns. Divide the code into different layers, and each of the layers have different responsibility. Let's start with the Lambda folder. The Lambda is the entry point of our applications. For the Lambda design, I follow the concept of single responsibility. So each Lambda will have only one single job. Inside the Lambda, I invoke the controller. The controller will expose the functionality of our applications. For example, in the create to-do method of this to-do controller, I process the incoming request, process the response back to the client, and handle any service errors that happen during our code executions. The main business logic of the application will lie inside the service layers. So for example, in the create to-do method, I set out the type, the ID, and status, create and update time. If I need to fetch or retrieve data from the database, I put that logic into the repository folder. As you can see from here, inside this to-do repository, I set out the table name, partition key, and sort key. All these values need to be matched with the one in the CDK code that we go through earlier. Finally, in the model layers, I define the actual data structure of our application. In here, I have one interface to do. I set out some type for its attributes, and the status will be a enum of created, in progress, and completed. So that is the basic walkthrough of our folder structure. There will be one more thing I want to mention. In this application, I follow another programming concept called inversion of control. Inversion of control basically means that we try to decouple the dependency between classes, and we invert the control flow of the implementations. What do I mean by saying that? Let's look at this to-do service class. It has two dependencies, the logger and the repo. So instead of writing like this, if I write like so, by doing that, I specify that the to-do service will have the implementation of the logger service class. But if I follow the concept of inversion of control, I just set out the abstraction in here, the iLogger service interface or the to-do repository interface. So if we look at the repository to-do, you will see that on the top we have the to-do repository interface. And the to-do service only know about this interface only from this slide. And the to-do service does not know, and in fact, it doesn't need to know anything about here. Under here is the actual implementations of the to-do repository. So you guys may ask, what is the actual benefits of implementing this inversion of control? Inversion of control gives us many benefits. It will improve the code modularity to shape our code base into independent, interchangeable modules, much easier for us in the future to maintain and test. For example, in the future, if I want to have another database, let's say a MongoDB database, all what I have to do is create another class that implement this interface. Let me show you quickly. So let's assume I have a new class called to-do repo Mongo, and in this class I implement this interface. I forgot to mention there is one place that there will be a connection between the actual implementation and the interface that is inside this container file. So in this container file, I set out whether with this interface, what is the actual implementation I want to bind it into. For example, in here, I bind it to the to-do repository. Now I have to create a new to-do repository. Or what I have to do is I import it in this container. So let's say here to-do repo. And instead of the previous repo, I can just change it to this one. So by doing this, now our to-do service class will have the to-do repo with the MongoDB implementation. So as you can see, I don't have to rewrite any code inside the to-do service class. And for the testing purpose, for example, if this table is this to-do underscore DB table is for our production environment, but if inside the dev environment, I don't want to write data or retrieve data from this table, I can just create a new class. Let's say export class to do repo dev, and then I again implement the interface. And in there, I set out the table name that I want to point it to. Let's assume it's to be like to do dev underscore db. And then in the container file, once again, I change the actual implementation to the one I want to point it into. To do dev and to do dev. Here we go. We successfully change the implementation from the real to-do repository, the production one, to the development one. So let's say I have some code right here, right? To check the environment, whether it's dev or prod. Then decide the actual implementation of the dependencies. So we are pretty much very flexible. What is the implementation we want to be for our to-do service class right here? I use dependency injection throughout everything in this code applications. And when this dependency will be resolved, it will be resolved at the beginning of the Lambda. So as you see from here, before the Lambda handler got called, I use the container.get to retrieve the controller. So when the controller is resolved, any dependency inside this to-do controller will also be resolved as well by the code inside this container file. And in order to implement this inversion of control, I use a technical dependency injection. I install two new packages. Let's look at the package.json file. The package is called Inversify. It's a very popular npm module. And then also I have to install the reflect metadata. I will put the link to these two repositories in the description. And also don't forget, in the tsconfig file, you guys have to enable two things: the decorator metadata and the experimental decorators. It simply is something that you have with the annotation like this at the beginning of the class or the constructor. So that should be it for the code walkthrough. Now, once again, I will use the CDK deploy command to update the change to the CloudFormation stack. This process will take some time, so once again, I will fast forward the video. So our CDK deploy command has finished. Now let's jump back to the Postman to test our API. So I have the Postman collection open right here. We will start with the first API that's called create to do. So let's duplicate this one. And if you guys still remember, the path will be to do. And the method going to be post. And inside the body, I was expecting to have a content. So I put in the content as first, let's call it do shopping, and let's send. Okay, so it's the server returned 201 status created successfully. So let's create another to do. Let's say I want to clean the house, and then walk the dog. So the create to do is success. I change it here to create to do and hit save. Now let's test our get to do API. So once again, we duplicate this one. The get to do will be a get method, and once again the same path. In the body, we don't expect any body, so let's it's sent. Okay, let me make it a bit bigger. So as you guys can see now, because in the create to do, we create two to do tasks. So in here we walk the dog, clean the house, and do shopping. So the get to do is completely success. So the get to do is success. Once again, I save it here. Save. Now let's set our update to do Lambda. So in here, duplicate, move it underneath, change the name to update, and the method is going to be post. As I mentioned earlier in the video, if you guys as I mentioned earlier in the video, the reason I chose post instead of patch or put is because for some unknown reason, if I'm using put or patch in the response body, I don't receive anything from the Postman. So we stick with post for now. So let's try to update the first to do. So I will grab the ID and put it in the path parameters right here. And if you guys remember, in the update to do, I will update the status of the to do. So I will expect it to be status. And it's going to be in progress. Let's send. So the first to do walk the dogs has a status in progress. So if we come back to the get to do and make another request, we don't expect to have a error. Oh, okay, there's no response here. It's supposed to be here. It's save, send. Okay, so the first to do now has a status of in progress. So our update to do is success. Finally, we test our delete to do. So once again, we duplicated this one. And this time the method going to be delete. and we follow the same format of the update to do. So we have an ID here. Let's delete the first to do using each ID, or also you guys can come back to the get to do and grab any of this ID. For example, I want to delete the clean the house to do. Let's grab this ID right here, and here put in as an ID, and it's going to be delete to do. And this one we don't expect anybody as well, so remove it. I can simply put none, and I hit send. So status of 202 accepted. So I save it now and save. So now if I go back to get to do and hit send, we only have 2 to dos left. Let's do one more quick sanity check by going to AWS console to see if it's stored in our database. So I have the AWS console open right here. If I go to the DynamoDB under tables tab, to do _db table, explore items, you will see that we have 2 documents right here. So that should be it for this video. We have successfully deployed our DynamoDB using CDK and also update our backend code. We apply some programming principles such as single responsibilities for the Lambda or inversion of control for our code base. As usual, I will update the Postman collection in our code base and put the link of that code base on the GitHub in the description of the video. Thank you guys for watching. Apologies, it's quite a long video, and I see you guys in the next episode.